I've always been wondering, now why do companies like Google and DeepMind are running after building AGI? Why do they want AGI systems to happen? Why do they want to discover and build artificial general intelligence, right? So the man behind Google and DeepMind, his name is Demis Hassabis. So he's the original co-founder and CEO of DeepMind. He has been working on AGI from ever since, I think even before than OpenAI. Now he identifies as a scientist. His primary identity is a scientist. He's not like an executive. Before an executive, he's a scientist, right? And he frames AGI as a meta tool. Now we'll talk about what exactly is meta tool. Now the main thing is that his identity, his philosophy comes from being a child chess prodigy, and he was exposed very early in his childhood to video games, to reinforcement learning, to algorithmic thinking, and thus the curiosity and the curiosity of what an AI system can do, started from that. And right now he frames AGI as something like an expression to human inquiry, an expression to what exactly is possible using AI. So he has made deliberate effort to understand the algorithmic level of the brain, the structural architectures that allow the biological brain or the biological systems to generalize the knowledge across domains, because he wanted to correlate it with the AI systems of today. So Demis thinks of AGI, artificial general intelligence, as a meta tool and as an ultimate expression of human inquiry. Now, what exactly is a meta tool? So he wants to use it as a meta tool that can help us progress in almost every domain. I mean, we can use AGI system as a meta tool, and it can help the human evolution progress in every domain possible. He frames that the purpose of AGI is not only to make money. AGI is our collaborator, our partner in scientific discovery. An AGI system will be able to do almost everything a human being can do. Along with it will also be able to make new scientific discoveries, like just like an original scientist can do. It will be able to come up with its own conjectures, and it will be able to prove those conjectures, and will be able to claim that scientific discovery. So Hassabis describes his motivation as an obsessive pursuit to understand all the big questions in the universe, and especially that are behind philosophy and physics. Now, coming to the main thing, we understand his obsession and his philosophy behind coming up with AGI systems and thinking about AGI as a meta tool, and especially as a meta tool for scientific discovery and being our collaborator and partner. But now, what exactly, is going to make AGI happen according to him, right? So the first thing is he describes that it is in fashion to ask always same question about LLMs, that have LLMs hit the ball, right? So first thing is he describes and he points out that LLMs are going to be, or any large foundational model going to be, a key component. So the only question is whether it is going to be a key component or it's going to be the only component, in an AGI system. So he disagrees with Jan LeCun, who is the chief scientist of AI at Meta, where Jan LeCun describes that LLMs might not be helpful in building or helping us to build AGI systems, right? So he disagrees with the fact. Now the second thing is he also emphasizes a lot on that people keep on saying that we have exhausted out all the data and there is no data available. There is no new data available for pre-training and training. He keeps on emphasizing that there are still a lot of things that we can extract out. There's a lot of juice in the pre-training, in the training, and in the data, and in the current large language models paradigm that we can extract out to innovate and to scale up. So he does not close the door close the door on scaling. He is still betting on scaling the existing systems that might lead to AGI. So scaling laws, applying scaling laws and scaling existing systems that might lead to AGI is not the definite answer that he claims. But he still thinks that, DeepMind and Google should keep on investing the research time and the innovation time on scaling the systems. It might not be the only bet, right? He describes a couple of other things that they want to do, but this is also a very big priority that they are looking forward to and that they are betting on. Now, one more question that he has answered around LLMs. So, LLMs are thought of as goldfish. Like if you try to query an LLM and ask it to search on the web to get to or to fetch some results, it's going to fetch the results and maybe present it to you, but it's going to forget, right? Especially in this query inferencing model, right? He does not completely closes the door on LLMs, right? He emphasizes three very important parts. One is longer or more efficient context windows, right? Longer might not always be the answer, but he believes that we need to innovate on, having longer or more efficient context windows. Second thing is continual learning, right? And third thing is memory. So these are the three bets he wants to take to improve and to innovate on these current systems, on the language model systems, where the innovation or the breakthroughs might lead to better systems that might be closer to it, right? So now now scaling them and solving these problems does not only mean that we keep on scaling with respect to data, parameter, and model complexity and compute. It also means that we innovate, right? And wait for, he emphasizes this very strong point that we innovate and we wait for one to two more breakthroughs before an AGI system happens, right? So just like we had a breakthrough and innovation in the first LLM when the transformer paper was introduced and when Gemini and ChatGPT came into picture. So that was a very big breakthrough. So he's visualizing or he's imagining that we might have one or two more breakthroughs before we have AGI systems. Now, one more point that he makes, which I really like, that while talking about AlphaGo and AlphaZero, he was emphasizing that learning is a very crucial part of an AGI system or of any AI system that is capable of doing new scientific discovery, right? So a system that has to discover something new should also have potential to learn, right? And learning is also correlated with intelligence, right? Learning does not only mean learning or learning the model parameters, it also means intelligence, right? So when when we talk about LLMs and if learning is symbolic to intelligence, and these models like LLMs, they don't have an ability to continually learn, right? So as we said earlier, that they have something like a goldfish brain, right? They can search the internet, they can search the web, fetch the results that you really want, combine them in a JSON or combine them in whatever format you want, maybe in a document or a sheet, give it to you, but they cannot learn from that, right? So the paradigm of continual learning is still to be solved and has not been fully solved. Now, the main unknown or the main degree of uncertainty is how do we master, how do we solve continual learning, and what is Demis's point of view and what is DeepMind doing to solve continual learning. So he points out, I remember seeing his podcast and he was pointing out that AlphaGo and AlphaZero, they have shown or demonstrated the ability to learn, but obviously in narrower domains. So before we understand how AlphaGo and AlphaZero demonstrated continual learning, in their own narrow domains of chess and solving Go, first we want to understand what is the core problem. So the core problem with LLMs or with all the AI models today is that we freeze the weights after we have trained, right? Whenever we train a new model or whenever we retrain an existing model, we freeze the weights and then we use the frozen weights for inferencing, right? So that is what is stopping us from continual learning. So now to learn something new, we usually train either completely from scratch or maybe we retrain an existing model, right? So these kind of models also suffer from something known as catastrophic forgetting, right? So to learn something like B, to learn to so catastrophic forgetting is where learning a task B causes them to completely forget the task A, right? So now I think it's going to be more relevant if we think about AlphaZero and AlphaGo and how they aim to learn. So AlphaGo originally learned by mimicking humans. It used a database of 30 million moves from human experts to get a head start, and then refined the knowledge through its self-play, right? Whereas AlphaZero, it threw away all the human data. It started with zero knowledge, right? And it literally started playing random moves and then learned entirely by playing against itself, right? So this is a very good example of continual learning. Whereas the new AlphaZero, it looked at the original AlphaZero's logic and it proved that it could generalize. Now, using the same algorithm, it mastered chess, it mastered Go, and it also mastered other games like Shogi. But when we talk about learning here in these narrow domains, and why we have not cracked it for our general system, but why have we cracked it for games like chess, right? If you think about it, chess has deterministic set of rules, right? And in a game like chess, the rules are never changing. There is a clear win and a clear loss, right? So learning in an agentic environment can still be predictable or can still be thought of, right? But in the messy real world where there is so much non-determinism and uncertainty, there is no clear win or loss. There is no deterministic set of rules that that an agent or that an AI system has to perform, and that is only going to be correct or that is going to lead to a path that we can declare as win or loss, right? So the rules are very vague. And the feedback is obviously noisy, right? The feedback is not that you have won or that you have lost. So if an AI learns from a bad interaction with a human, it might permanently degrade its performance. If an AI system learns from a good interaction, then it might, right? And good and bad can also be subjective in both of these contexts. So good and bad can also be subjective in both of these contexts. So the dying question is still open, that all of these current AI models that belong to the modern AI umbrella, they are obviously great at learning during the training phase. But can we just put them in the wild and ask them to learn continually, right? And the other question is, now that we have seen in narrow domains like chess, there is a path to continual learning. We have seen it in the existing systems of AlphaGo and AlphaZero. Can we scale it to the world? Can we scale it to the messy real world data? And can we apply those techniques with the language models? And Demis naturally believes that the answer is yes, right? So, three breakthroughs that we might expect from DeepMind is on continual learning, on longer memory, and on longer and efficient context windows. On, if we talk about the current language systems before AI or AGI happens.